We're down here for the Robotic Technology Kernel Reg Dev. It's our regular development cycle where we test and integrate new software before we release it into our RTK product line. We have a lot of partners for the Robotic Technology Kernel. Southwest Research Institute is one of our primary vendors that we work with closely, and we come down here frequently to test our vehicles. They have a lot of different terrains and test tracks that we can use to put the vehicles through their paces to make sure the software we're delivering is going to be robust for the different scenarios we need it in. So the Robotic Technology Kernel provides a lot of autonomous capability that allows platforms to get autonomously from point A to point B, and that allows the soldier to have higher situational awareness of things that are going on around them, so they don't need to worry about like, oh, what's my platform doing? And it gets the soldier out of harm's way in a lot of cases too, that they can have these platforms out in front of them, getting into those more dangerous environments, but then also not having to worry and babysit them constantly. So we're really trying to move on the spectrum from constant oversight to not even thinking about it anymore. I think we've got a long way to go to get to that point, but we're making quite a bit of progress from early days where it was straight direct teleop, where you had to constantly be monitoring it, to the point where there's trust being built with the soldiers, to the point where they don't even have to think about it anymore, and that the platforms will just get where they need to be. So we've made a lot of improvements in like perception, navigation, and bringing in new capabilities from different projects. So I'll start with on perception. We've primarily been very LiDAR heavy. We're starting to look again at bringing in some vision perception back into the pipeline.
We're starting to add some newer cameras back onto our platforms for things like material classification and then detection of objects and obstacles in the view. So we've set up a whole new pipeline that's GPU based that mimics a lot of standard machine learning or AI approaches for computer vision, and we're doing some just very basic applications to test out that pipeline.
We're also looking at some navigation upgrades, so increasing the op tempo of our different path planners so that when they encounter obstacles, they're a bit more deft at getting around them and maintaining speed.
Previously, one of our sort of main path planners is something called KREITER, and what KREITER tries to do is register a route that you give it, so a series of waypoints with an area of low cost, like a road or a trail. You provide it with that series of waypoints, but if there's an obstacle along that path that you gave it, it's not designed to deliberately avoid it. The vehicle will slow down for that obstacle. It won't hit it, but it won't actively plan around it. So the work that we've done in the last few months is to add another sort of obstacle avoidance module that can run on top of KREITER. And so if the route that you provided does intersect with an obstacle, it will sort of deform the path around that obstacle and allow you to maintain a higher speed.
We have a dynamic object tracker, so this is kind of like vision adjacent. We're using radar for this, and we're just using it to kind of track dynamic objects in terms of other vehicles in the scene, so that way as you're navigating, you're not having to stop as frequently when a vehicle slows down or when they stop in the scene.
If you're driving down a road, there might be debris on the road, right? So it's pretty important to be able to avoid that, and you don't want to have to come to a stop and enter some kind of replanning behavior. You should just drive around it. The human who's providing the path initially is obviously not going to know that that debris is there. So this is sort of a prime use case.
We're currently underway on doing a major architecture change to how we have our LiDAR drivers feed into our navigation system. The genesis for this is that we want to improve the support for multiple different manufacturers of LiDAR. The LiDAR community has really started to grow through automotive and other companies kind of pushing it forward. So we now have a lot of different providers of sensors that are starting to compete with each other and show promising results in different areas. So on some of our new vehicles, we're going to have more of a wide range of different LiDARs stationed around the vehicle, and we want to make the support of feeding that data into the system a lot easier and make it where it's not as complex to swap sensors in and out.
And then also with bringing in new behaviors from autonomous ground resupply, which is our large convoy effort. Previously, that had been on its sort of like an isolated code base. but we're bringing that over into the RTK platform, and then that's going to all be RTK. So that also means that all of our RTK platforms will have that option for that convoy operation too, using that same technology that was developed under AGR. I expect RTK to be around for a long time. We're building that platform that is common across all the Army's ground robotic systems that can be the focal point for new technologies to come in and transition onto those programs of record. We're working on that transition piece right now to those big programs, but I really think there is a lot of potential there in having that common platform that enables this quicker transition to occur, where it's not just these big monoliths of software, that we're doing continuous upgrading, continuous integration, continuous development and testing, so that way the soldier is always getting the best software as soon as they can.